Here students, observe students, which of the following is not correctly ordered for resonance stability? For resonance stability identification, what is the first rule? Number of covalent bonds. More, stability is more. Second rule, neutral molecule is more stable compared to charged molecule. In this first option, in these three, first molecule have 8 covalent bonds, second molecule 8 covalent bonds, third resonance structure 7 covalent bonds. These two are more stable compared to this one. This is the least stable here. So this is charged molecule. This is neutral. So neutral molecule is more stable compared to charged molecule. This order is correct order. Next option C. Observe that option C. 3, 4, 5, 6. How many covalent bonds are present? 6 covalent bonds. 3, 4, 5, 6, 7. 7 covalent bonds are present. This resonance structure is more stable compared to this one. This order is incorrect order. So option is C. This is incorrect option. Next, which of the following lone pair indicated is involved in the resonance? Which lone pair is involved in the resonance? This lone pair is localized lone pair, that is not involved in the resonance. Localized lone pair. Next, this lone pair is present in the inside to the ring, that is involved in the aromaticity. So that is involved in the resonance. So option B is the correct option. This is not involved in the resonance. This is not involved in the resonance because of conjugation is absent. Next, which of the following rearranged carbocation is more stable than below given species? Compared to this carbocation, which carbocation is the most stable carbocation? Observe the degree. This is primary carbocation, this is primary carbocation, this is tertiary carbocation, this is secondary carbocation. First of all, you know that hyperconjugation. What is the hyperconjugation? sp2 carbon. Carbocation is the sp2 carbon connected with sp3 carbon. That sp3 carbon having one hydrogen. The carbon hydrogen sigma bonding electrons moving like this. That is called as hyperconjugation. Number of hyperconjugation structures increases, stability increases. Stability increases. This is sp2 carbon connected with sp3 carbon. That sp3 carbon only one hydrogen, one hyperconjugation structure. This is sp2 carbon connected with sp3 carbon. Two hydrogens are available, two hyperconjugations. This is sp2 carbon connected with sp3, connected with sp3, connected with sp3. 7 hyperconjugation structures. This is more stable. Next question, observe students. Which of the following is not a resonance structure of others? So observe here, this is the conjugation is present, here also conjugation is present, here also conjugation is present. But in this structure, between these two bonds, it is separately existing. Conjugation is not present. So conjugation is not present, it is a different molecule from the three. So option A. Next, among the given set, which represents the resonance structure? Resonance structure meaning is what? Delocalization of pi electrons. Delocalized pi electrons are present, not atoms. Not atoms. In the structures, atoms are not moving from one place to another place, only delocalization of pi electrons. Observed here in the first molecule, carbon, nitrogen, oxygen. But in the second molecule, oxygen, carbon, nitrogen. Connectivity is different, so it is not a resonance structure. Next, observe the B. Oxygen, carbon, nitrogen. Oxygen, carbon, nitrogen. Connectivity is same. Oxygen, carbon, nitrogen. Oxygen, carbon, nitrogen. Only delocalization of pi electrons. Third molecule, carbon, nitrogen, oxygen. Oxygen, carbon, nitrogen. This is not a resonance structure. This is also not a resonance structure. This one is a resonance structure. Resonance structure meaning is electrons are moving from one atom to another atom. Not atoms are moving in the structures. Next, which of the following species will not show hyperconjugation? What is the hyperconjugation? sp2 carbon. Carbocation is the sp2 carbon. Or alkene, double bond carbon also sp2 carbon. Connected with sp3 carbon. Connected with sp3 carbon. That sp3 carbon having hydrogen. That hydrogen involved in the hyperconjugation. This is alpha carbon. This is alpha carbon. Having at least one hydrogen. That hydrogen, carbon hydrogen sigma bonding electrons moving like that. A is the toluene connected like this. This is sp3 carbon connected with sp2 carbon. So hyperconjugation is possible. This is sp2 carbon connected with sp3 carbon having two hydrogens. Hyperconjugation is possible. This is sp2 carbon connected with sp3 carbon. Hyperconjugation is possible. This is sp2 carbon. Here the sp3 carbon hydrogen is available, but that is bridged carbon, bicyclic compound. At bridged carbon, double bond formation is not possible. That is not involved in the hyperconjugation. So simply option D. Next, which of the following alkenes will show maximum number of hyperconjugation structures? So here this is sp2 carbon, this is sp2 carbon. sp2 carbon connected with sp3, here the sp3, two hydrogens are available here, here the three hydrogens are available, five hyperconjugation structures in this side, five hyperconjugation structures, so overall 10 hyperconjugation structures in this molecule. In this molecule, here three hydrogens, six hyperconjugation structures. In this molecule, 3, 9 hyperconjugation structures. In this molecule, 0 hyperconjugation structures. Reason, no alpha hydrogens, here the no alpha hydrogens. This is sp2 carbon, this is sp3 carbon. sp2 carbon, sp3 carbon. Students, remember here the sp3 carbon which is connected directly to the sp2 carbon, that carbon having hydrogens, those hydrogens involved in the hyperconjugation, not next carbon. This is sp2 carbon, next carbon is alpha carbon, next carbon is beta carbon. Beta carbon hydrogen, beta carbon having hydrogens, but that is not involved in the hyperconjugation. Only next carbon having the hydrogens, that is alpha hydrogen, that is only involved in the hyperconjugation. Next, 43. Next question, observe here the decreasing order of bond length CC double bond in the following compounds. Resonance is more, bond length is more. This is the benzene molecule, that electrons are delocalized, double bond is converting into single bond is converting into double bond. Alternatively, existing bond length is more here in the third molecule. Next here, two pi bonds are present in the conjugation, that is resonance is possible, double bond is converting into single bond. After this is the molecule. Next here, why this the third this one is existing before the fourth? Reason, hyperconjugation. Number of hyperconjugation structures here 10. In this molecule, number of hyperconjugation structures are 4. Delocalization of pi electrons are more here. So this is the next. Next, observe here, students, which of the following is not a aromatic compound? Not an aromatic compound, the question. You know this molecule name, that is thiophene. You know this molecule, that molecule name is thiophene. Here sp3 hybridized carbon is present, sp3 hybridized carbon is present, that is non-aromatic compound. This is tropylium cation is aromatic compound. This is furan, aromatic compound. Option is B. Next, decreasing order of potential energy. Decreasing order of potential energy of the following cations. Observe the number of resonance structures every molecule. These molecular ions are resonance structures. Number of resonance covalent bonds, observe that in the every molecule. So here number of covalent bonds are more. Covalent bonds increases, stability increases. So which molecule having the more number of covalent bonds? I am counting here, check once. 3, 4, 5, 6, 7, 8, 9, 10, 16 are there. In this 3, 4, 5, 6, 7, 8, 9, 15 are present. Next year 3, 4, 5, 6, 7, 8, 9, 10, 16 are present. 16. So potential energy, which one is more, which is the least stable? So second one is the least stable, potential energy is more. Between the comparison, on the oxygen positive charge is present, on the nitrogen positive charge is present, on covalent bonds are same, on more electronegative element positive charge is present, that is least stable. So here option